Welcome back, mathematicians. We are now working on the final review before the final. So this is the last time you'll ever have to hear my voice, hopefully. Kidding. So I decided to choose 2 problems from each exam, and they are the most missed problem. Either partial credit wise incorrect, so either people just didn't get it correct most of the time, or there were a lot of partial credit misses as well. Okay, so the first 2 are going to be from exam 1. The first most missed problem is from 1.6, and it's problem 81 in the textbook. And the question states, the half-life of a certain radioactive substance is 36 hours. There are 19 grams present initially. All right, cool. And then we're asked, part A is to express the amount of substance remaining as a function of time. And we're specifically told that time, T, is in days. All right, so half-life with radioactive substances, the equation for that is, I like to use in the form y equals y naught e to the kt. So the reason we're using this one and not I think a 1 plus something, whatever that one 1 plus r, is because radioactive substance, it's continuously being there's always there. I don't know how to explain this. It's kind of the similar as compounding continuously. I'm always going to be having some part of the substance that is going to decompose. All right. So in this case, y naught is our starting value, and it is 19 grams. And I'm going to make a note that T is in days. So our half-life isn't 36 hours. I can't put 36 in. That's going to be 36 days. It's going to be 1.5 days. We can also make that 3 halves if we wanted to. 36 divided by 24. All right. So let me move this up, and then let me move this down. That looks like enough room. Okay, cool. So I need to find, I have y naught, e is just a number, t is also just an input, so I need to find k. All right, so half-life means that in 36 hours, or 1.5 days, if I started with 19 grams, I'm going to have half of that. So I'm just going to write 19 divided by 2, half of 19, is going to equal 19 e to the k, and then t divided by 1.5. So the reason I'm doing this is because if t is in days and my half-life is in 1.5 days, I need it to be, when I plug in 1.5, I need it to be 1 half-life cycle. All right. So I would actually have t divided by 1.5 here, and then we'll rewrite it a little bit because you're dividing by 3 halves, and we can rewrite that. All right, so these kind of cancel, and that just becomes 1. I'm going to divide by 19 so that I get 1 half equal to e to the k. Well, now I need to find what k is, so I know I can take the ln of both sides, and ln of e, and then the k will come down because it's an exponent. So I just get ln of e is just 1, so I just get k. So I get k is ln to the 1 half. Okay, I was incorrect. This is still my way. But that's fine. We'll move everything down. So then I need to put everything together. So I have y equal to, not y naught, I know what that is, it's 19, e to the k, which is ln of 1/2, times t divided by 3/2, and then I'm going to rewrite this as 19e to the ln of, so this is kind of a nice little trick because I know you'll want to cancel out this ln and this 1/2, but I can't because this t divided by 3/2 is in the way. So I need to do the reverse of what I did right here, where I had a coefficient from the power after I ln. So I need to make t to the 3/2 a power of 1/2. So I'm gonna have 1/2 to the, I'm gonna write it t to the 2 times 2/3, just because having a fraction in the denominator just doesn't feel right. All right, and now I can cancel out this e and the ln. And then I'll get that it's 19. So then this will come down, and this will be 1/2 t times 2/3. All right. So that is our final answer. You could have absolutely just left it like this, I'm pretty sure. This is the more simplified way in red. And it also will help you a lot later on plugging it in. So now we need to find when there will be 11 grams remaining. Sneak preview. Whoa, I didn't know I could do that. Okay. So 11, so we're trying to find when y is 11, what is t in hours? I forgot to write that in the questions, but that was given. So we're gonna find t in days, and then I need to multiply by 2040 in hours, okay? So 11 equals 19 1/2 2t over 3. So I'm going to divide, and I get 11 19 equals 1/2 2t thirds. And I need to find what t is. So I'm going to ln both sides to get that exponent to become a coefficient, get everything on the same playing field. So I'm going to have 2t divided by 3, ln of 1/2. And then I can do ln of 11 divided by 19. And I'm actually going to change that to be negative ln of 2, just for simplicity's sake. So 2t over 3. Things kept being in my way. Okay. So then we can, you guys are going to be able to use a 4-function calculator on your final. So I'm going to plug that into my, maybe a scientific one because it's ln's. ln 11 divided by 19 divided by negative ln of 2. And this equals 0.7884 equal to 17 divided by 3. We're going to multiply each side by 3/2. And so I get that t equals 1.1827 days. But I want my answer in hours, so I multiply by 24. So that t equals 28.385 hours. And I think it just wanted the closest hour, and it was 28. Okay? So, well, I really didn't give myself enough space. Okay. Bear with me right here. Just because I need to move. Oh, no, no, no. How do I move it back? I had this beautiful drawing. There we go. We're going to cut. We will paste. Beautiful. Okay. So, second most missed question was to find the point xy at which the graph 9x squared plus 2x minus 3 has a horizontal tangent. So, section 3.1 was our first chapter in finding derivatives, right? So we had just kind of talked about how to estimate them, I think. I can't remember. So we have a few things going on. I need to understand what a horizontal tangent means, and I need to know how to find one. So horizontal tangent is when the tangent is a horizontal line to the graph. So if I have this curve, my horizontal tangent is, that's not a horizontal tangent. It's gonna be an actual horizontal line. That's not very good, but you get the point. So it's gonna be when y prime equals 0. We now know, after doing a lot of curve sketching, this is also where max and mins can occur, or not critical points, yeah, critical points. So we're gonna take y, we're gonna find y prime. So the 2 is gonna come down from power rule, and I have 18x plus 2. I'm gonna set that equal to 0, move that 2 over. X is equal to negative 2 over 18, which is also just negative 1 over 9. Cool, well that's an x. I need the y part of it as well. So I need to plug back into y, and I will get plus 2, negative 1/9. Minus 3. So then we can simplify, so this is going to be 9 times 1 over 81, or we can just put that all together. So 9 divided by 81 minus 2/9 minus, and let's make 3 something over 9. So 3 is 27 times 9, so then 3 is going to be 27 over 9. All right, 9 divided by 81, that simplifies to 1/9 minus 2/9 minus 27/9. 1 minus 2 minus 27. So 1 minus 2 is negative 1, minus 27 is negative 28 ninths. So our final answer needs to be in the form of xy. So I would write my answer, negative 1/9, oops, comma, negative 28 ninths. Ta-da! Okay, cool. So, do we have room for this? No. Oh my gosh. Okay, we're gonna move this up. We're gonna move this down. Okay, cool. So this is one of my favorite related rates problems. So this is top missed problems from exam 2. Exam 2 went from 3.2 to 4.3. So 3.2 was the derivative of the function, and then we went all the way up to the first derivative test of finding max and min. So this exam was kind of just all about derivatives. Exam 1 was kind of mentioned derivatives, and we kind of were setting up to figure them out with learning about different functions and limits, and now we're actually into the derivative stuff. So a balloon is rising vertically above a level straight road at 3 feet per second. Just when the balloon is 70 feet, I don't know what this extra is. Just when the balloon is 70 feet above the ground, a bicycle moving at a constant rate of 15 feet per second passes under it. How fast is the distance S of t between the bicycle and the balloon increasing 6 seconds later? So the good thing looking back on these things is now I know a lot more stuff about keywords that I might not have known right then. I now know this word increasing means that a derivative is going to be positive, right? Decreasing negative, increasing positive. It's asking me how fast the distance between something is changing. It's a rate, so I want to find what S prime of t is. All right, so related rates, you kind of need to construct your own equations, right? We were given this picture in the problem, which is pretty neat. So we kind of know that we're going to be working with triangles. And I know a lot of different equations for a triangle. So I like to kind of write down everything I know. So I know, so at time, let's do it, t equals 0, y of t, so the balloon was 70 feet in the air, x of t, so this starting point is like the origin, this is time 0, and x of t will, bike, x of t, so x of 0 is actually going to be 0, right? The bike was directly under it, so horizontally speaking, it was at its starting point. So the distance between these two is 70, which I don't think we really even need. Just fun fact. So at t equals 6, if I start at 70 and the balloon is going up, how fast? 3 feet per second. That's going to be y prime. 3 feet per second. We're also given x prime. It is 15 feet. No? Yes, 15 feet per second. So if I start at 70 feet and I'm going 3 feet every second for 60 seconds, so that's going to be 70 plus 3 times 6. 3 times 6 is what, 18? So this is going to be 88. X6 is, so I started at 0, and I'm going to be traveling 15 feet per second for 6 seconds, so that is 15 times 6, which is 3 times 30, which is 90. And then S of 6 is, how do we find that? Yes, the Pythagorean theorem, and I don't know where, oh, there it is. Couldn't find my phone to do this math. So this is going to be, $88 squared plus 90 squared. Because we're doing, ooh. And I'm going to take the square root of that. So it's the square root of 15844. which is 125, 87 feet. Okay? Don't even know if we need that information, just for fun. So I found that out because I know that s of t squared plus x of t squared plus y of t squared. I know those two sides are equal. That's a Pythagorean theorem, right? A squared plus b squared equals c squared. C squared is the hypotenuse. So, related rates, I'm going to take the derivative with respect to time. This kind of falls from implicit differentiation and other stuff. What am I thinking of? Chain rule. Okay. So I'm going to take the derivative of this with respect to time. So we'll just say like d dt. So I'm going to, power rule says that I'm going to take 2 times s of t times s prime of t equal to 2x of t, x prime of t, plus 2 y of t, y prime of t. All right, and if you're confused about how I get this, the 2 comes down. So 2 s of t is like this function, my inside function s of t, and my outside function is something squared. So 2s of t is the derivative of the outside with the inside still the same, times the derivative of the inside. And I do that for each term. Thankfully, all these 2's cancel out. I could collect a 2 on the right-hand side, divide it over, and it would go away. And I'm finding how fast the distance s of t between the balloon is at 6 seconds. So I want to find this guy. So let's plug and chug. So every t is going to be 6, so good thing I have this. And since these are constant rates, this is true for any time. So 3 and 15 will work at time 0 and time 6. So what's s of t? 1.2587. You can also leave that as a square root. Okay. S prime is at 6 equal to x at 6, which is 90 times x prime, which is 15, plus, what's y? 88 times 3, and then I'm going to divide that by whatever s of t was, which is 125,874. Great. And that will give us a number once I figure it out. Oh my gosh, they have been mowing and I don't know what outside my house all week. So we get 1614 divided by 125.874. And we get 12.822. And since I was given lots of units, I should give units back. So this is going to be feet per second. Okay, great. So the second most missed problem on exam 2 was this one. I actually really like this problem. Because when you guys were first given this problem in your homework, you didn't know how to take the derivative, and we had just learned about left hand and right hand derivatives. But now we know more about derivatives, so we can do this problem a lot faster. So determine the following point y, that's PW. Defined function is differentiable at x equals 0. So we're given that f of x equals 4x minus 1 when x is greater than or equal to 0, and x squared plus 4x minus 1 when x is less than 0. So it kind of walks us through this problem. For something to be differentiable, it means that the difference quotient as h goes to 0 exists. Well, a limit exists if the left-hand limit and the right-hand limit equal. So if these two equal, we got a derivative at that point. If they don't, we either got a cusp or the derivative just is also piecewise and it's like crazy, doesn't even connect. So first you need to find the right-hand derivative. So when h is going from 0 plus, that means when h is approaching 0 from points greater than it. So, I'm trying to think of how to explain this. So that means that f of 0 plus h, or let's say this, yeah, that means 0 plus h, this inside bit right here, is going to be greater than or equal to 0. Actually, it's going to be greater than 0. So that means I'm looking at when 4x minus 1 is my function. Okay? So we're not going to find the difference quotient to do that because now we know derivatives. So I can just kind of look at the derivative with respect to x of 4x minus 1. And I know that that is 4. Perfect. And that would be a value when x equals 0. But we were just lucky enough that it's a constant, 4. Okay? If you wanted to do the limit, you would do 4 from 0 plus h, which I'll just put h, minus 1 minus 1, plug in 0 for that, over h, and then I forgot my limit, never do that, and stuff like that, okay? So if you include your limit as h goes to 0 plus, you will get that answer there. But the key here is that since 0 plus h is numbers greater than 0, we're looking at this first function in our piecewise. Okay, great. Now I can gain back some area because I gave too much room. So now what's the left-hand derivative of the given function? So now we're going from when h is less than 0. So that means that 0 plus h is going to be less than 0. So we're going to find the derivative of x squared plus 4x minus 1. And we're going to evaluate that when x equals 0. Because that's what I care about. I care about finding the derivative at 0, if it exists. So I know how to take derivatives. It's going to be 2x plus 4 evaluated at when x equals 0. So 0 plus 4 is just 4. Perfect. So let's been putting everything in a box when it's the right answer. There you go. Oh my gosh, all this real estate I'm getting back. It's free real estate. Okay. So is this given function differentiable at x equals 0? So our, whoops, we're in red. Yes. And the reason is because the limit as h goes to 0 of our difference quotient, I should have put 0 in for x. So the limit of the difference quotient exists because the right-hand limit equals the left-hand limit. Yay! Okay, so now we're on to exam 3. Exam 3 was 4.4, which is when we did a lot of curve sketching with concavity, and all the way up to 5.6, which is some integral stuff. And I'm looking for, when do we do optimization? We did optimization on this exam, but that wasn't the most missed problem. I love that cow problem. So find the area of the shaded region. It says on the right, and the graph is on the right. So it should be the shaded region on the graph because the graph's on the right, not the right area of the region. Okay? So, I have two curves, the slanty one, which is 2x squared, and y equals 4 minus 2x. I'm also given that this goes from 0, and then they meet at 1, I think, and 2. And this goes all the way up to 2, I believe. All right. We are actually going to make sure that's all true, just for practice. So I want to make sure that where that graph meets. So we're gonna have, let's call y1 equal to 2x squared. Oh my gosh, what is happening outside? 4 minus 2x. Okay, and we're gonna set those equal to each other. So 2x squared equal to 4 minus 2x. So I get 2x squared plus 2x minus 4 equal to 0. I can divide everything by 2, so x squared plus x minus 2. I keep getting this. X minus 2, no, x plus 2, x minus 1, because 2 minus 1 is 1. Okay, cool. So they're going to intersect at x equals 1. I don't really care about negative 2 because that's not in my shaded region. I'm kind of told right down here at 0 and 2. That was in the picture given. So if I have two curves, so if I'm trying to find the area between two curves. There's two ways to do this problem. I can solve for x in these problems and do it from the y-axis. I don't really suggest doing that because I think it's easier to do it using x's. Because I'm going to split this into two areas. The area between 2x squared and the axis from 0 to 1, and the area between 4 minus 2x squared and the axis between 1 and 2. Since those 2 points, just those two graphs, hit at x equals 1, and there's no point where like one's on top of the other. Like I'm not trying to find the area like of right here. That's not it. So I'm gonna have my area equal to 0 to 1 of 2x squared dx plus, not 0, 1 to 2 of 4 minus 2x dx. So not the area between the curves that you might have expected. All right. So we can integrate. So I'm going to get 2x to the third now. Divide that by 3. I'm going to evaluate that from 0 to 1. Plus, what, 4x minus x squared from 1 to 2. I'm kind of brushing through integration a little faster just because I expect you guys to be pretty familiar with how to take the antiderivative of reverse power rule. All right, so I'm going to plug and chug. So fundamental theory and calculus, I plug in 1 and then subtract when I plug in 0 for this first term. So that leaves me with 2/3 minus 0 plus, let's plug in 2, which is going to be, what, 8 minus 4 minus 4 minus 1. So I get 2/3. I don't need to say minus 0. Plus 4 minus 3. So I get 2/3 plus 1, which is 5/3. Okay? Like I've kind of been saying, the hardest part about these like curve problems is figuring out your integral, which is kind of what was it going to be? It's kind of up to you how you want to do it. Whatever you think is like better. I could have made this like one integral and like turned it sideways, but I think making two integrals is not too bad. All right. So the other most missed problem was a curve sketching problem. So that's good that we get to review that. So 4.443 asked to graph the function below and find any local and absolute extrema and inflection points. If you don't remember this problem, it was like a fill in the blank multiple choice problem, and you got to choose some graphs at the bottom. So you're first asked to find any local extrema, and then you're like, oh, the max is here, doesn't have any, blah, 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 local, whatever. Okay, so we're gonna find local extrema when y prime equals 0. So let's find y prime instead equal to 0. So y equals, this is something of x divided by something else of x. So I'm going to do quotient rule. So going to do low, which is x squared plus 9, d high, which is 9, minus high, d low, which is just 2x, all over x squared plus 9 squared. Okay? And I'm going to set this equal, that should be y prime, this equal to 0. So local extrema also happen when the derivative is undefined. So I need to find when the top is 0 and the bottom is 0. So let's set the top equal to 0. Let's also kind of distribute. So this is what, 9x squared plus 81 minus 18x. And I'm actually going to pull another 9 out. I'm going to pull the 9 out again. So x squared plus, minus 9x plus 9. No, 2. There's supposed to be a 2 right there. Okay, so that 9 can go away, and then don't know things that multiply to 9 and add to -2. Okay, so let's do the quadratic formula. So x is equal to -b plus or minus b squared, which is, wait, no. Sorry, the square root of b squared. So 4 minus 4, 1 times 9. Did I do this right? Hold up. So then this only gives me imaginary things. So this is never 0. Imaginary. Okay, cool. So this is always positive. That's good to know. So that didn't give me anything. So now I'm going to look at the denominator, which is x squared plus 9 squared. So, right, x squared plus 9. So -9. What the heck? That's what I get for not going through this problem like I did every other problem. Oh, I see it. That's a square. Okay, we're back on track. Wow. My apologies. I was like, why am I getting a quadratic? Okay, cool, yeah. So, this makes so much more sense. 9 minus 18. So negative 9x squared plus 81. Oh, hell yeah. There we go. This is so much better. Okay. My apologies for the brain fart. Okay. So then set that equals 0. So this, I'm going to get 9x squared equal to 81, or x squared equal to 9. There it is. So x equals negative 3 and 3. Okay, cool. So these are my critical points. Don't know if they're mins, don't know if they're maxes. I have to test them. I'm gonna have to find the second derivative in a little bit, but like, don't know if I really want to do that right now. So let's do the first derivative test. So I'm going to have, whoa, okay. Negative 3 and 3, drop down. Okay, cool. So I'm going to plug in, let's see, 0, 4, and negative 4. And those are my x values. I'm going to plug those into y prime. So y prime up here, notice x squared plus 9 squared. That's always going to be positive. So I'm not even going to plug it in there because I don't really care. It's always going to be positive, so it's not going to change my sign. So plugging in negative 4, I am, let's rewrite this because I wrote it up top. So what was it? Negative 9 x squared plus 81 over x squared plus 9 squared. So I plug in negative 4 and I'll square it and I will get 16 times negative 9. And that's 144, or sorry, negative 144 plus 81. Still a negative number. So that's a negative. If I plug in 0, I'll just get 81 over a positive number, so that's positive. And if I plug in 4, I'll get the same thing for negative 4, since I'm just squaring it. So I'll also get a negative. So that means I am decreasing, increasing, decreasing. So going down, up, and back down. So down, up, down. So that means right here at negative 3, I have a minimum, and at 3, I have a max. So depending on what your multiple choice options are, I think they're like local minimum at this place, local max at this place, and one answer gives you 2 options, and then a local max is only here, there's only a local min, it's only here, and then there's no local extrema. So in this case, I would choose the one that said local min at x equals negative 3, local max x equals 3. Now you need to read the question or the answer box, because if you come back to me and you're like, oh, I didn't read that very well, so I put the wrong answers in the wrong box, I'm like, well, that's a wrong answer. I can't, like, first of all, I can't even give you partial credit. I mean, I could, maybe. But if you tell me that there is a max when there's actually a min, I really don't know if you know how to find a min and a max. I can't trust that, all right? You can find when the derivative equals 0. You should have been able to do that for a while, all right? So now we're going to find inflection points. So that's when the second derivative equals 0. So I simplified my first derivative to help me find my second derivative. So y prime equals, what is it? Minus 9x squared plus 81. You can also rewrite that so that there's not a negative in front. And then x squared plus 9, that quantity squared. So now we're going to find the second derivative of that. So it's going to be low d high, so that's negative 18x minus, I'm going to write it 81 minus 9x squared, just for funsies. So low d high minus high d low, so that's going to be 2x squared plus 9, derivative the outside of the inside still the same, times the derivative of the inside, 2x. That's a lot easier to take the derivative instead of foiling that and then taking power rule, in my opinion. And then this is all divided by x squared plus 9, that quantity squared. So we'll just make that to the fourth. So we need to find when this hoo-ha equals 0. Well, my denominator can never equal 0, just like it couldn't last time. So I'm just going to set the numerator equal to 0. So I'm going to have x squared, let's do this, negative 18x, x squared plus 9 squared minus, what, 4x, that's from these two, 4x, 81 minus 9x squared, x squared plus 9. So I know what you're thinking. Oh man, I have to like multiply these things out. Not necessarily. I'm going to show you a cool trick. Hopefully make your life a little easier. Each one of these terms has x squared plus 9 in it. This one actually has 2 because it's squared. So I'm going to pull it out. And I'm going to pull it out because it's always positive. And dividing, it's never 0. So it's never going, I can divide by it. I'm not divided by 0 secretly. So I'm going to have negative 18x, and that leaves an x squared plus 9 right there, minus 4x, 81 minus 9x squared. So nothing too bad right now. All right, so then I can divide that over. That can never give me 0 because we deal with real numbers. And then what are we going to do? Let's multiply some things out. So negative 18x times x squared is going to be negative 18x cubed minus 18 times 9 is like 2 times 9 times 9. So it's 81 times 2, which is 162. Let me double check that number. Yeah, okay, 162x minus 4x times 81 that is going to be 2 times 62, which is 324. X minus 9 times 4 is 36, so that's plus 36x cubed. Okay, now to combine like terms. So 18x plus 36x cubed. Actually, let me just with 18. So I'll get 18x cubed (162 minus 324). It's gonna be minus 486x. Cool. So I can pull an x out. So I get, oopsies. X equals, x times 18x squared minus 486. Therefore, x equals 0 is an inflection point, or possible inflection point. And then 18x squared minus 46 is going to be equal to 0, and I can just make that 18x squared equal to 486. So that means that x squared equals 27, and 27 is 3 times 9 squared, by the way. So when I take the square root of that, that's going to give me the square root of 3 times the square root of 9 squared. Well, not 9 squared, just 9, which is 3 squared. Dumb. Ah. And that's how I get plus or minus 3 root 3. So these are just all possible inflection points. Now we need to test them. I can rewrite, rewrite y double prime. We're gonna say that it is equal to, so this whole part, I'm just simplifying it right here, all the way down to right here. So it's gonna be x times 18x squared minus 486. Oops, no. Times x squared plus 9, because I kind of got rid of that earlier. Yeah, cool. Over, boop, x squared plus 9 to the 4th. The reason that x squared plus 9 is coming back into play is because I took it out earlier, but it's, I mean, it is, you don't really need it in there, but it is, that is what y double prime is. Because it's always gonna be positive, so it's not gonna change my, outcome of my inflection point test. So I'm gonna have 3 square root of 3, 0, 3 root 3. So remember that 3 root 3 squared is going to be 27. That's going to help you when we're plugging into this. All right, so we're going to plug in square root of 3 is greater than 1, so it's actually like 5.19. Okay, so I can plug in like -1 and 1, and then we can plug in like -6 and 6. Great. Something I can easily square. So those are my x's. I'm now going to plug into y prime. So I get -6 times 18 times 6 squared. So 18 times 36. Wait, is that 6 squared? Yeah. Which is going to make that part a positive times a positive. What I'm doing is I'm going through each one of these little things and plugging in my x value, which is this guy right here, -6, and I'm seeing if I get a negative times a positive times a positive. So I get negative times positive times positive, so I get a negative back out. If I plug in -1, I will get a negative times a negative times a positive. Also, this is all divided by a positive, so that's why I'm not doing that part. And that gives me a positive, so that means that -3√3 is an inflection point. If I plug in +1, I get positive minus positive. Yeah, it gives me a negative, so that 0 is an inflection point. And for +6, I will get positive times positive times positive. So I think the question gives it to you x equals, so that is a hint that you don't want to put in an xy coordinate. So I would say that I have inflection points at x equals 0, 3√3, and -√3. Oh, sorry, -3√3. If you're confused about what I'm doing with negative and positive, again, I'm plugging in to this little x and then 18x squared minus 1 times something else, because I only care about the sign. I really don't care about the number. As long as I'm getting a positive number, I'm concave up and then I'm concave down when it's negative. As long as those numbers change from positive to negative, I'm good to go. Okay? So now we're going to choose our graph. So I want something that has a local, min at -3 and a local max at 3 and inflection points at 0. So I can also see, looking at this graph, where's my original function, the limits as x approaches infinity and -infinity are going to, oh, my exam closed. I left it up so that I could look at the pretty functions. Where is this problem? Excuse me. What? Oh, it's problem 1. So as x goes off to infinity and -infinity, this whole guy is going to 0 because the bottom's going to get really, really big. So I can write that out. Limit as x goes to positive infinity of 9x over x squared plus 9 is going to equal, I write positive 0. That's important. 0 from the positive side, okay? And then the limit as x approaches -infinity, that bottom part's always going to be positive because of the x squared plus 9, but x squared plus 9, you could do L'Hopital's rule because I would get infinity over infinity, but since x squared is the higher number and it's in the denominator, it's going to take power and go off into infinity. So I'm actually going to get -0 here, and I'll show you why. Because our graph, I now know, has a horizontal asymptote at where? 0. I don't have any vertical asymptotes because, as I've said many times, x squared plus 9 cannot ever equal 0. So that means as -infinity is going on, this is coming from 0 from the bottom, and then I'm probably going to have, I have a min at -3, so let's call this a -3, and a max at 3, and an inflection point change at 3√3, which is like somewhere right here. And so I have that I'm concave up when I'm a min. Why are you that? So this is gonna kind of look like changing concavities and changing concavities again. Kind of like that. And I think that was the graph that you guys were shown. So you kind of need to use a little bit of more of the curve sketching knowledge to choose your graphs, other than I know that there's a max and min at these 2 points, and then you need to narrow it down more. Do I have any horizontal asymptotes? Do I have any vertical asymptotes? That'll help you out a lot. Okay, I think the other two graphs they give you in here are when it's like x squared minus 9 on the bottom, because it looks like there's 2 vertical asymptotes. Cray. All right, I think that is all the questions that we have today. I'm sorry if this video was super long. My bad. Good luck on your final. You guys are gonna do great, and please do your homework.